We have an application on friction on inclined planes. So we are told to find the force applied and required to move a load of 300 newtons up a rough inclined plane. The force being applied parallel to the plane. The inclination of the plane is such that when the same load is kept on a perfectly smooth plane, inclined at the same angle, a force of 60 newtons applied at an inclination of 30 degrees to the plane keeps the same load in equilibrium. Assume coefficient of friction between the rough plane and the load to be 0.3. So we have two cases in the same problem. Here we have a body that is uh, that weighs 300 newtons, and then it has a force, okay, that is applied to this body on the inclined plane parallel to the plane. So we have one, let's call it force P, is parallel to the plane. This is of 300 newtons, and it has an angle of inclination alpha. So we have on the same plane with the same inclination, we are told that when this same body, okay, is moved on the inclined plane with a force, let me call this this same force P at an angle of 30 degrees to the plane, okay. So the inclination of the plane is such that when the same load is kept on a perfectly smooth plane, inclined at the same angle, a force of 60 newtons, this is 60 newtons, applied at an inclination of 30 degrees to the plane, keeps the same load in equilibrium. So now this is case 1, this is case 2. So if we look at case 2, case 2 says that the same load is kept on a perfectly smooth plane. So in here, phi is equal to 0. But here, phi is not equal to 0. So, but do we know the force, okay, force applied at an angle to the plane to move the body upwards the plane, the inclined plane. That force, if we call it maybe P2, the single prime can equal to, because we already derived this in our past lectures, so we are just going to quote it. We know it is equal to W sine of alpha plus phi divided by cos theta minus phi. Okay, theta is the angle of inclination, phi is the angle of friction, and alpha is the angle of inclination of the plane, okay, which is not known. So alpha is not known, theta is known, and phi is also known, because phi we can obtain it from arctan of 0.3. It is given, okay, because we know tan phi is equal to nu, which is equal to 0.3, because nu is the coefficient of friction and is equal to 0.3. But in case in case 2, we are told that the plane is smooth. So no friction. No friction. That means our P2 will equal to W sine of alpha plus 0 divided by cos of theta minus 0. So what is this? This one is known as 60 newtons equal to 300 newtons sine of alpha divided by cos 30. So what is sine alpha is equal to cos 30 times 60 divided by 300. So cos 30 times 60 divided by 300. And this is equal to 0.17321. So alpha is equal to sine arc of 0.17321. And this is approximately 10 degrees. So I've gotten alpha, which is the angle of inclination. Now from case 1, friction is not equal to 0. And the force that is required to move this body, okay, at just at the point of sliding upwards, we know that friction would be moving downwards. Okay, and the force that will be required to move this body parallel to the plane will equal to that force P. Let's call it P2. Okay, force required to move the body parallel to the plane upwards. P2, if we call it P2, we also earlier on derived this in one of our videos, and then this is equal to sine of alpha plus phi divided by cos phi. So we already know that alpha is equal to 10 degrees. We know phi is equal to arctan of 0.3, and this is, so arctan of 0.3 is equal to 16.7 degrees. So what does that mean? So our P2, okay, will therefore equal to W, which is 300 times sine of 10 plus 16.7 divided by sine of 16.7. It is a cos divided by cos. So this will be so sine of 26.7 divided by cos 16.7, I multiply by 300. So the answer is 140.73. So the force required is equal to P2 and is equal to 140.73 newtons.